Classify the following as rational or irrational with justification. So we have 3 root 3 divided by 12, so on and so forth. So when we look at it first, everything has a root, it has to be rational, is it not? Well, before deciding anything, talking about terminating recurring and non-terminating recurring and so on and so forth, right? Okay, anything over here, you guys have to simplify. For everything, you have to simplify. Post simplification, you guys can decide on things. I'll add that information over here. Actually, I missed it out. So post simplification, right? We can decide on rational and irrational. Only after simplification, remember, it's very important. Okay. So now, what does simplification over here mean? Well, we have 3 root of 3 divided by root of 12. I'm just rewriting, nothing else. Okay. So can I write 3 times of 3 by 12? Can I do this? Why? Because a to the power of n by b to the power of n is a by b whole to the power of n. Agree? So that would be this one. A to the power of n, b to the power of n is a by b whole to the power of n. Is it not? And then we have 3 1s are, 3 4s are, and so this is 3 into, this is 1 by the way, remember, 1 by 4 root or root 1 by root 4. Okay, again, same formula but other way around. Root 1 is what? Root 1 is 1. What is root 4? 2. And so we have this to be 1.5, which is a terminating number. Is it not? So when we look at this, it doesn't look like rational, but it turns out to be rational, that to terminating. Okay. Now, similarly, all the questions we have to simplify and then decide on things. So we have root 5 plus 3 root 5 into root 5. So first thing first, we can use board mass, right? Let's see inside the brackets, can we do something regarding this? We can actually. This is 1 root 5 plus 3 root 5, that is what? 4 root 5. And outside the brackets, we have root 5. And since we have root 5 into root 5, that is root 5 square, we can cancel root and square, and we have 4 into 5, which is 20. Okay, and this too turns out to be rational. The answer is it's rational. Justification, as it is, well, as it is an integer, I guess. I mean, not integer, but there's no, well, irrational number multiplying or dividing over here. You know, it simplified to this. So exactly what should be the justification? Let me think about it. Let's solve this first though. Next we have root 2 into root 8 minus root 6 plus 2 root 3. Okay, let's see what to do. See, first thing first, I always ask you guys to simplify stuff, right? Like root of 8. What can we write this as? Root of 4 into 2. Agree? Which further can be written as root of 4 into root of 2. How? ab whole to the power of n is a to the power of n into b to the power of n. Is it not? So this is from this formula. Where is it? Over here. ab whole to the power of n is a to the power of n into b to the power of n. Now, what is root of 4? Root of 4 is your 2 root 2. Root of 4 is 2, and you have root 2 left out. Then we'll take root of 6. Root of 6 is root of 3 into 2, and then we have root of 3 into root of 2. We can't do much about it, so this is it. And now back to the solution. So we have the solution being equal to root 2 into 2 root 2 minus root 3 into root 2 plus 2 root 3. Okay, so the only thing that we can do is we can't add anything over here. We can actually take root 2 common, or we can use distributive property and multiply root 2 with both of this. So let me just multiply it off. 2 into root 2 square, okay, minus root 3 into root 2 square plus 2 root 3. And then we have root and square getting cancelled, and we have this to be 2 into 2, 4 actually, minus this is 2 root 3, right, plus 2 root 3. So if you want any clarification over here, okay, so just root 2 into root 2, a into a is a square, as simple as that. And we have root of anything is nothing but a to the power of 1 by 2. Since we are raising it to some power over here, like square and all of that, so that will be basically 2 by 2, is it not? This funda has to be used. Okay, more examples you guys can write it over here, that's why the space. And now we have what? We have two like certs. So these two are like certs, and so the answer is 4. Is it not? These two are like certs. Okay. Similarly, we have a last question. I'm thinking of changing it though. It's similar to the first one. Okay, that can be your homework. So this 2 is what? This 2 is rational. Okay, all of these are rational because they don't have any irrational number multiplying or dividing them. I don't know exactly what is the justification for things being rational. It's terminating. Here too it's terminating. Here too it's a terminating number. And this also will result in a terminating number. Okay. Or terminating. This will be, I think, wait, this is 3. Yeah, this also is terminating. So for all the answers, it is rational as we have a terminating number as the final result. So this is the answer for all of it. Right, this is, I mean, we are telling the obvious. Because they've asked us to write the justification, we have to write something. And that something should make sense, obviously. We can't just write anything. So this makes sense and we are done. Okay. So again, please learn the basics properly. After this chapter, don't think about exponents to be difficult. So now you can pause and have a look. Again, any doubt, always clarify with anyone who is available to you guys. Any kind of source is okay. So answer for this, I think, is 932. Okay, should be getting 2.